and then we'll move on into the heart block. So I'm going to turn the camera around, and I hope everything shows up good on here. I apologize if it's a little fuzzy. I'm sitting on our table and we're outside of work right now. So in one cycle of the heart's conduction, it goes from the P to the T wave. The P wave is where the top of the heart, the atrium, depolarizes. Sorry, I had a moment there with my brain. So the atrium pumps the blood down to the ventricles, and you get the QRS complex that the ventricles depolarize. And then the T wave is where the ventricles repolarize and they get ready for the next round. The PRI, or the PR interval, is from the start of the P wave to the start of the QRS complex. That's going to come into play with our blocks here in just a minute. So on the paper here, you can kind of see, it's a little fuzzy, but you can see the small boxes inside these larger ones. And I've drawn a picture of it out here. And I hope you can see this. So each of these small boxes here is 1 millimeter, and that equals 0.04 seconds. And one whole box is 5 millimeters, or 0.20 seconds. So for a first degree heart block, your PR interval is greater than the 0.02 seconds. So I've drawn these, so I do apologize if they're not consistent and straight. But you can see here that the P wave starts right here on this line. The next line here at the 0.20 mark is where the cutoff is for a first degree heart block. So anything with a PR interval greater than 0.2 seconds, in this case here, is a first degree heart block. And you can see that maintains all the way out through here. That there's more than 0.2 seconds. And I do apologize, that's not regular. That was my hand drawing it. We're going to move over here. See. So then we're going to move into our second degree type 1, and in the second degree type 1 you start out with a very short PR interval like normal, and if you notice, it gets a little longer and then it drops one right here. There's not a QRS complex. One of the ways I remembered how to remember a type 1 was short, long, longer, drop. That's the way we Wenke block, because the type 1 second degree heart block, the other name for it is a Wenke block. So yeah, short, long, longer, drop. That's the way we Wenke block. And there's your second degree type 1. Your second degree type 2 doesn't have the lengthening of the PR interval. It carries out like normal, but then it randomly will drop one, and it can be every couple beats, every other beat. It can just vary. So for the type 2 second degree, you don't get the lengthening of the PR interval like we've got up here. You just carrying on, and you drop the QRS here. The third degree heart block, or the complete heart block, there's no communication between the top and the bottom of the heart. You can have a narrow QRS complex like we saw earlier. Let me bring this other paper back over here. A narrow complex QRS is anything that is 0.12 seconds or less. So when you're looking at the boxes here, and I apologize about the lighting, when you're looking at the boxes here, your QRS, for it to be considered narrow, can be no longer than 3 boxes. It is not very common to see a narrow complex in a third degree heart block. Most of the time in a third degree heart block, you've got the wide complex like I've tried to show you here. I traced this off of another strip But with the complete heart block, like I said, you don't have any communication between the top and the bottom of the heart. So your P waves just march on out here, but there's no set association with your complexes. And as you can see here, there should be another one here, but it's buried behind the QRS complex, so you actually cannot see it. The 3rd degree heart block is the only rhythm that I have found, that I know of, where it has actually have the ability to hide the P wave like that behind a complex. No set. I know this is just a short strip here, but if you were to carry this on out, this wouldn't necessarily be something that repeats every 3 beats. It may never repeat in this same order with these same PR intervals and things of that nature. Like you see here, there's a P wave with no complex, another P wave with no complex. The ventricles are carrying out their own thing at their own pace, and the atria are carrying on their job at their own pace, but they're not communicating. I hope this helps y'all, and if you have any questions, feel free to drop a comment below, and I will do my best to get back with you. Have a good night.